Hello, everyone. Sorry for the technical difficulties. We had some issues getting up with our first ever live stream, and thank you. And today we'll be talking about the new 500-year flood standards, what code officials need to know. I'm Andrew Moore, Marketing Manager with ASCE Publications, and I'm glad you're here with us today. Communities across the country continue to experience significant flood damage, even when structures meet current code requirements. That gap between design assumptions and what we see on the ground is a major driver behind recent updates to ASCE 722 and ASCE 2424, including the shift to the 500-year floodplain. No sound. Today's session is designed, sorry, I was looking at the chat, we're still new to this, and I will continue because now I can confirm you are hearing me. So today's session is designed to help you understand why these changes were made, what they mean in practice, and how they may impact jurisdictions working toward adoption. We're fortunate to have with us Jeannette Torrents, Technical Director of ASCE's Structural Engineering Institute. In her role at F.SEI, Jeannette leads key technical and professional initiatives and collaborates with engineers and volunteer leaders across the country to strengthen the structural engineering profession. Before joining ASCE, she spent more than 2 decades in structural engineering practice, including leadership roles overseeing teams and complex design projects. Her combined technical experience and behind-the-scenes access to how these standards are made make her the perfect person to guide us through these updates today. Before we get started, a quick note on engagement. We encourage you to participate. Feel free to add comments or questions at any time in the chat field. Everything will appear as a comment directly in the LinkedIn event post. If time allows, we'll answer a few live questions at the end. Anything we don't get to, we'll follow up on after in the comment thread. With that, I'll turn it over to Jeannette to begin. And Jeannette, you're live.
Me?
Okay, Jeannette, good to go.
Thank you. So today we are talking, as Andrew said, about the 500-year flood standards. Thank you for your patience as we do our first ever LinkedIn Live. I want to be respectful of everyone's time. And so if you're not able to stay for the full time now, we will be recording and we'll post it on our YouTube channel later so that you do have access to the full presentation. So before we dive in too much, I just want to ask everyone to please be respectful of copyright and AI usage. Just don't use these slides for commercial purposes or upload them into AI without permission from ASCE. So the 2 flood standards we're going to be talking about today are ASCE 7, which provides minimum design loads, and ASCE 24, which provides requirements for flood-resistant design and construction. We're actually talking about the latest edition of ASCE 722, which includes Supplement 2, which is available for free download at the ASCE library. So why do we have changes to our standards? Well, if we go to what was previously in ASCE 7 and ASCE 24, those were based on flood events and flood requirements that were last revised in 1998. Those 1998 requirements were actually based on 1973 National Flood Insurance Program minimums. So now we have nearly 50 more years of data and the benefit of comprehensive studies from the U.S. Army Corps of Engineers that form the basis for these new, modern, consensus-based standards. If we take a look at some of the issues with the previous flood provisions, they were based on insurance criteria, not on target reliability criteria. The flood hazard mean recurrence intervals were not specific to risk category. They did not include the effects of sea level change. And most importantly, they did not prevent losses. So if we look at annual flood losses in recent years in this bar graph, you'll see not only are they of significant magnitude, over time, the trend is increasing, not decreasing. So as we get started, I really want to make sure that everyone is on the same page with what we're talking about when we mean recurrence interval and are talking about a 100-year event, what it is and what it is not. So a 100-year flood event is the flood event with a 1 in 100 probability of occurring in any given year, which means that it has a 1% annual probability of exceedance. What it does not mean is that if we have a 100-year event, we won't see another one for the next 100 years. Annual probability actually ends up compounding over time, just like compound interest on your bank account. So if you look at a 100-year flood, that actually has a 26% chance of occurring over the life of a 30-year mortgage, basically the same as drawing a spade out of a deck of cards. If we look at a 500-year flood event, that will be the flood event with a 1 in 500 probability of occurring in any given year, which has a 0.2% annual probability of exceedance. These events are also more common than you may think. Houston recently experienced 3 500-year flood events in a row. How is that possible? Well, it's important to remember that the probability that any extreme storm will happen is completely independent of the probability of the next one. If we go back to our card analogy, it's as if after you draw the card, you put it back in the deck and the deck is reshuffled before you draw again. So I want to take a moment and have everybody think about what this means to them. If you were making the standard, what probability of flooding would you accept over a 50-year period for your community? Would you be comfortable with 5%, 10%, 20%, or would you be willing to go to 40%? After you've taken a moment to think about that, let's look at the mean recurrence interval events that would be required to align with each of those probability of flooding. The 40% probability of flooding aligns with our current standards of close to a 100-year event. The new standards that we're talking about today provide much more or closer to a 10% probability of flooding during a 50-year period. That's where we have the 500-year event for most structures. And if we look at the MRIs that accompany the 5% and the 20%, perhaps the 1,000-year event doesn't seem quite as extreme after all. So here are the requirements for mean recurrence interval by risk category. So ASCE 7 uses risk category, ASCE 24 uses flood design class, but they're both doing the same thing. They're taking an event and they're targeting it to an acceptable risk level based on the occupancy and use of a structure. So for our agricultural type buildings, we're still at a 100-year flood. For most structures, including residential, risk category 2 will be at a 500-year event. For risk category 3, which would include things like schools, we're at 750 years. And for our most essential facilities, hospitals and fire stations, risk category 4, we're at a 1,000-year event. So not only are we talking about different events, that also corresponds to flood hazard area. So just as a review of the flood hazard area or the floodplain that we're looking at and we're requiring flood to be taken into account when we do design, the 100-year floodplain is the area of land that is inundated by the 100-year flood event. With the new standards, we're taking that flood hazard area and we're taking that out to the 500-year floodplain, which would be the area of land that is inundated by the 500-year event. What is the difference between the 100-year and the 500-year floodplain? The answer is it really varies on where you are across the country. So let's take a quick look at that. This is a screenshot from the free ASCE hazard tool. This is Miami, Florida. And you can see that the area in blue is the 1% annual chance flood hazard, which, as we just described, is the 100-year flood event. If we take a look at this 0.2% annual chance flood hazard, that's going to correspond to the 500-year floodplain. And you'll see here in Miami, there's a sliver of this sort of peach color here, but it's not very extensive compared to the 100-year floodplain. Contrast, if we look somewhere like Denver, Colorado, you'll see that when we look at this 500-year, it's actually quite extensive and is covering a lot of area that previously would not have been subject to flood requirements. And we're going to talk about why that's so important in a moment. So let's review what the old elevation requirements are for non-coastal structures, looking at our different risk categories. We had our risk category 1 buildings set at the 100-year elevation, which we also call the base flood elevation or BFE. Risk categories 2 structures had a foot of freeboard to help with protection. It's also where risk category 3 were. Then a risk category 4 had an extra foot of freeboard for protection. We look at our coastal requirements. In the old standard, our risk category 3 buildings were also up at BFE plus 2. Now, something important to remember is the previous standards were only taking into account the 100-year floodplain, but we were elevating structures to water levels that extend beyond the 100-year floodplain. So it should be no surprise that more than 40% of National Flood Insurance Program claims actually come from outside of the 100-year floodplain. So why this is so important to expand the floodplain and what we're looking at, I think is really illustrated by what happened with Unicoi County Hospital. So this is a hospital in Tennessee, relatively new. It was built in 2018, and you can see it here in this yellow circle. The hospital footprint is completely contained within the 500-year floodplain. So under the previous standards, it would have no design requirements for flood because it's not within the special flood hazard area or the 100-year floodplain. But in September of 2024, this hospital experienced an extreme flood with water levels up to 12 feet around the perimeter of the hospital. If we think about the old standards and just expanding out to that 500-year floodplain, it would have been slightly elevated at BFE plus 2, so it would have been up 2 feet. That would still have experienced 10 feet of flooding, which is significant, especially for an essential facility like this. If we're looking at our new requirements, that 1,000-year event we talked about, that would have had it up at 10 feet, which corresponds to 2 feet of flooding. So again, the 1,000-year event isn't something that will never happen. It isn't something that is going to provide complete fail-safe protection, but it would have significantly have reduced the impact on this particular facility. So let's take a look now at what that means when we're talking about our old elevations and how they correspond to risk versus our new elevations and how they correspond to risk for those different 40%, 10%, and 5% thresholds we were talking about earlier. So let's go ahead and construct our structures like we were talking about in the floodplain. Got our risk category 1, our risk category 2, inside and outside the 100-year, risk category 3, and risk category 4. When we have our flood event with a 40% probability of occurrence over a 50-year period, our current standards are fine. When we get to that 10%, our most essential facilities are okay within the 100-year floodplain. Facilities just outside of that, like the Unico Hospital, are not. And if we go to a 5% a 5% probability of occurrence within that 50-year period, you'll see that our current standards aren't doing what we need them to do. So it should be no surprise that in 2024 alone, the National Flood Insurance Program paid nearly $8 billion out in claims. So let's take a look at our new elevations versus our 50-year risk. So now we've got our structures inside the 100-year floodplain and within the 500-year floodplain, elevated to the same elevations by risk category. At our 40% event, everything is still fine. At our 10% event, our risk category 2 and above are not experiencing flooding. And then at our 5% event, our most essential facilities are still protected. Now, we do still have what we call the waterfall effect for risk category 3 and 4 structures that are outside of the 500-year floodplain. Since the 750-year floodplains and the 1,000-year floodplains are not yet mapped, we can't really understand the extent of what that needs to be, but this is still a significant improvement about what we had before. And in use, you can really think about making some educated decisions when your facility is close to the edge of that 500-year floodplain. So, how much additional elevation do we need to target in order to hit that 500-year mark? So, if we look at the difference between the 500-year elevation and the BFE plus one, on average across the country, this difference is only a foot. Now, if we're going out to the 500-year floodplain where we didn't have any requirements before, and now we're bringing them up to the same level, that on average is going to be about 2 feet. But it's important to recognize that flood hazard varies significantly across the country. So the difference between BFE plus one and 500 year depends on where you live. So you'll see in this map that lighter colored areas are the places with less difference, where BFE plus one was already close to getting you to the 500-year elevation. And then the darker areas are where it's not hitting the mark. So I talked about on average, we're in this medium gray area, which is about a foot of additional increase in elevation. But there are some areas in the country, if you look at these really dark areas like Texas Hill Country, where we're at about an 8 foot difference. And there it becomes an issue of not just possible flood damage to property and to the structure, it also becomes a significant life safety issue. So, how do we determine the design flood elevation, especially if our 500-year elevation isn't available? Well, you can always use a site-specific local study, but ASCE 24 does have this flow chart that you can step through. If you don't have the 500-year, you can calculate it based on the 100-year flood elevations or the information that you do have. Want to point out that Louisiana State University's Ag Center has created this free minimum required elevation calculator that's based on ASCE 24 that just basically steps you through this flow chart and helps you get to your minimum required elevation. So an important piece of this flow chart that we haven't talked about yet is that for coastal flooding locations, our design flood elevation is based on not just the MRI flood event that we were talking about, but also it has to account for sea level change. So what is the sea level change value? It's the historic rate of relative sea level change times the service life, or a single future projected value no less than 50 years in the future. Couple of notes on the historic rate of relative sea level change. We only want to look back no more than the last 40 years, and we'll talk about why that's important in a moment. And for our service life, we need to look at least at 50 years, which is the 50-year service life is really what all of the ASCE 7 loads are calibrated to. So why are we looking at sea level change? Well, according to NOAA, on average, the United States will see as much sea level rise by 2050 as seen in the last century. So that means even if we don't have significant storms, we're going to have increased coastal flooding just due to sea level rise. How much sea level rise? It varies, and that's again why there's not a set number in the standard. In the East Coast, they're predicting about a foot in 30 years, a little less than that on the West Coast, and more than that at the Gulf Coast. You'll notice that ASCE 7 and 24 use the terminology sea level change instead of sea level rise because there are certain locations in the country, such as Alaska near the Kenai Peninsula, where sea levels are actually going down because the land rising out of the sea is actually happening more quickly than the water levels are rising. So you have a net decrease. So let's take a look at our old elevations versus our 50-year risk for coastal when we have to look at the fact that we know that sea levels in most places are going up. What that means is that because of that sea level rise, we don't have protection, the same protection at that 40% level that we think we do, and much less at the 10%. And we're really not where we need to be at the 5% at all. So, how do we look at sea level rise? So, this is the U.S. Army Corps of Engineers Sea Level Analysis Tool, or SLAT. This is a free website, and you can pick a location. Here, I've picked a NOAA tide gauge in Georgia to take a look at the sea level data, and it has a record of 91 years that you can see over here on the right. If you scroll further down, it will do your projections for you. It will take a look at what that looks like. And so it has a sea level rise based on the full record of 91 years. And then it has one just looking at the last 40 years, which is what we require for 7 and 24. If we take that yearly rate of change and we project it out 50 years, saying we're going on a straight line increase, that computes to just under a foot of sea level change to take into account. However, you'll remember there was that OR method that you could also use in 7 and 24. What's important about this is there is this multi-agency report that was published, I believe it was in 2022, by several agencies: FEMA, USGS, the U.S. Army Corps of Engineers, NOAA, and several others, where they did projections where they said, it really isn't reasonable to assume that we're going to be continuing on this straight line basis and just extrapolating linearly. Things are increasing more rapidly than that. And so you can click on the chart if you toggle to these NOAA et al. 2022 projections, and you can pick a date, and it will show you a range of sea level change. And what's interesting here is for this, you'll see that in July 2070, on the low end, they're actually predicting 1.25 feet. So that's higher than what we had calculated with that linear piece. Again, the linear is the baseline of what you need to use to comply with the standard. But in order to make good choices for your community or for your project, it's important to take a look at this and understand how you want to, I would say, weigh the risk and benefit of your choices. So let's look at the new elevations versus 50-year risk for coastal. Because we have that sea level change baked in, you'll see that now we're hitting exactly the same performance for coastal as we are for non-coastal. And that's what's so important about this standard. By going to MRI targeted events and eliminating freeboard, by incorporating sea level change, we're now able to have a consistent level of protection across the country, no matter where you live. Whereas before, under the current standards, the amount of protection that you had when you designed to the standard was extremely variable from one place to another. Okay, so in summary, our new flood provisions are based on target reliability criteria, not insurance criteria. The flood hazard mean recurrence interval is specific to the risk category. They include the effects of sea level change, and they minimize potential losses. So where are we with this? We are about to go to the public comment hearings for the I codes. These are the newest versions of the reference standards that will be incorporated into the 2027 I codes, and ASCE and F.SEI, along with all of the partners that you see on the screen here, have put in code change provisions to accompany those. And then the last piece that I'll leave you with is that we have resources available for you, where we have the free download of 722 Supplement 2 from the ASCE library that I spoke to you about before. We have ASCE Amplify. If you have a subscription to that, you can see the standard and commentary side by side. You can also pull up the two standards next to each other, so you can compare 2424 to 2414 side by side. LSU Ag Center is the minimum required elevation calculator I told you about. The U.S. Army Corps of Engineers has the sea level analysis tool. ASFPM is working on model code ordinances to help walk AHJs through adoption, and FEMA has published this building designer's guide that walks you through how to calculate the flood loads using ASCE 722 Supplement 2. So with that, I will turn it back over to Andrew and ask if we have any questions that came in on the chat, but I do want to share our email with you. You can always put other questions in at SEI@asce.org and we will respond. Thank you.
Fantastic. Thank you, Jeannette. And I'm actually monitoring the chat right now for any questions. So we have Jennifer Gerbasi. What data was used to determine the risk of flood?
The risk of flood. So those events, the 500-year events, the 500-year floodplain, et cetera, those are on the maps that are generated by FEMA, and they're the national maps. So, but the way the standard is written, you can use those maps or you can use your own study as long as they're calibrated to those events that we talked about for the target risk.
Okay. And she also asked the source of the 12 feet of flooding in Tennessee.
The source of the 12 feet of flooding of Tennessee. My understanding is that was a riverine event, so it's not coastal, so storm. A very, obviously it was above 1,000-year event, so not a very likely storm, but a storm that can still happen, and when it does, has severe consequences.
And then there were a few people who asked if they could access these slides. I don't know if you're willing to do that, Jeannette, but or we can adapt these slides.
I think we can think about how we can make those available through ASCE. As you can see, I have a lot of animation baked into the slides, so I know if we just go with pure PDFs, they might be difficult to read, but we'll take a look at how we can make that available if you think that would be a helpful resource.
Okay. And then this just came in from a LinkedIn user. How can attendees today support the passage of ASCE 2424 at the ICC final action hearing next month in Hartford, Connecticut?
Well, I would say that for one, attending the code hearing, if you're a voting member of that body, makes a big difference. I think we have a lot of people who we already talked about, all the proponents that we have who are going to be coming and giving testimony and explaining why this is important. So I don't think we necessarily need more testimony at this point in time, but talking to your local code officials and telling them why this is important to you and important to your community, I think could make a big difference. And the truth is, where we go with the 2027 I codes and which portions of the provisions are passed and which are not, that doesn't preclude engineers and AHJs from still using the standards and making the decisions that they need to do to protect their communities. And ASCE is here to help be a resource for that, as I know ASFPM is.
And then Eric Renford asked, and maybe a little bit off topic, would these sorts of flooding standards be at all applicable to gas stations and other critical retaining structures?
So yes, I would say that the flood doesn't know what your structure is, right? So what we have here and the standards that are very specific about flood loading, which would be ASCE 7, and it talks about wave action and how to deal with that. And then 24, which has pieces about elevation and flood damage resistant materials. Some of that could be extrapolated to other types of structures, but this concept of understanding the probability and risk of those events, that's something that would be universal.
Okay. And last question I see so far, how can we integrate climate changes to our own modeling, for example, the 10-year flood event, since it's not provided with FEM maps or maybe FEMA maps?
So when I talked about that flow chart about some of the different things that you can do to look out further with one of the choices is if you know your 10-year flood event and your 100, you can project out to 500 and 750. That's not so much on the climate change piece there. We have a couple of climate change pieces we're looking at. The one in the current standard has the sea level rise, which some of that, as we talked about, is geological, but some of it is related to climate change. In ASCE 728, which we're currently working on, they are developing a future conditions chapter, which also looks at how does climate change potentially affect the intensity of storms and what that might mean for flooding in both coastal and non-coastal regions. So that's something that I hope we'll have more information about soon. And it's exciting to see structural engineers collaborating with climate scientists and seeing those whole Earth models that we have available to us.
And then we have, is there any correlation between the larger or smaller differences between the 100-year and 500-year flood and whether the topography is flatter or hilly?
I would say the topography makes a big difference. It also depends on the flooding source and what that looks like. If you think about if you have a very shallow basin, that water level is going to spread out more, and then the difference in elevation is not going to be as much. If you have a much steeper canyon gully type situation, the same amount of water is going to fill up a lot more. So that's why this uniform freeboard approach just isn't appropriate at all, because what we really are interested in is the topography. And you can see in some places, as we looked at, you can have not a big difference at all between the 100-year and the 500-year. On average, it's about 2 feet across the country, but in some places it's less, and in some it's significantly more.
Okay. And then perhaps the last question.
Okay.
So is the industry standard that the project structural engineer is expected to determine the DFE from maps similarly to earthquake design data in wind, or that B, the project civil engineer determines the DFE, and then there's a note, 2021 IBC section 1603 requires flood design data to be on these structural drawings?
So it really depends on what your AHJ is doing. I think this is an important partnership for the civil engineer and the structural engineer. I would say that in my experience, I would see more of the civil engineers tend to have the certified floodplain manager designation, but structural engineering and how that's working.
Okay. Any final thoughts, Jeannette, or anything?
I just want to thank everyone for sticking with us as we experimented with our first ever LinkedIn Live and figuring out the technology. I know we ran way over time, so if you made it through with us to the end, we appreciate it, and thank you for being here.
Yes, thank you everyone for your patience, and stay tuned for future programming. Okay, take care.